Good morning, everybody. We're going to be starting here in just a second. We are broadcasting on the internet live from Georgia Gwinnett College in Lawrenceville, Georgia, just outside of Atlanta. We have an audience here with us this morning for those of you who are viewing this on the internet. So we thank you for joining us as well. Would like to offer some special thanks to a few folks who have made this possible. First, Georgia Gwinnett College, who has graciously provided these facilities for us. This is the site of our first DSTAR InfoCon back in, when was that? About 5 years ago. So there we go, we're live. Also like to thank Icom America, who is providing our streaming this morning. They're also providing one of our giveaway items today. And we would be remiss in not acknowledging Internet Labs, who is one of them here, that one of our speakers and presenters today. With that, my name is John Davis, WB4QDX. On the far end of the table, we have Ed Woodrick, WA4YIH, who is best known for www.dstarinfo.com and all of the programming software for updates for your radio, which is one of the topics we'll be covering today. I mentioned Internet Labs. You have Robin Cutshaw, AA4RC, who's beside me here, the inventor of the DV dongle, DV access point, the D+ software that runs on many of the repeaters around the world. And the wizard below the stage here is Ray Novak, N9JA, who is your official title is video producer today, but in charge of the sales for the amateur radio division and some other duties today. So we'll be covering, all of us will be contributing during the day today. We've had a lot of questions that have been submitted in advance. We'll try to cover as many of those as we can. We appreciate all of those that have been submitted via the internet. We also will be taking questions from our local audience. And we also have a way that you can submit questions live. If you operate with DRATs, then you can go to our Ratflector, which we'll be using today, courtesy of the Georgia Aries organization. So that Ratflector is gaaries.ratflector.com. And if you will submit your questions via the chat page on that, we'll be monitoring that, and we'll try to get to as many questions as we can. Again, that's gaaries.ratflector.com. And we'll be monitoring for your questions and try to take as many of those as we can. All right, here's some of the topics we're going to be covering today in our 4 hours with you here. I'm going to start off talking about, I'll call it DSTAR 101. How many of you here in the audience are brand new to DSTAR? I know a couple of people have spoken up. We've got a few here in the audience. So we'll try to cover some of the very basics of DSTAR. We'll move into some additional topics, setting up, programming, and updating your DSTAR radios. Ed will be covering that. We'll spend a few minutes talking about the new Icom radio, the ID-51Plus2. We'll also cover the additional DSTAR radio, the Kenwood THD74A. We'll talk about DSTAR devices and the many ways that you can access the DSTAR network. This will be directed more toward some of you who are responsible for repeaters, but we'll talk about the new G3 gateway software, which is beginning to show up on repeaters around the world. And of course, we want to take questions from you.
By the way, John, we already have a question.
And that question is?
Is today's event being recorded?
Yes, it is. Good question. Not only are we live streaming, but this is being recorded. So you'll be able to watch this again at your leisure on the Icom America YouTube channel.
You may also want to mention that we're delayed because our audience here sees something very different.
Yes. Due to the miracles of the internet and streaming, what you're seeing on the internet is a little bit delayed by about 25 to 30 seconds on the internet, but you're getting a live feed here for our local audience. I want you to hang around today. Make sure that you registered at the table out front. If not, make sure that you do. We're going to have a giveaway at the end of today's session. Unfortunately, it's only for our on-site participants. So your odds are much better than if you're on the streaming audience. We have two giveaways today. One is an ID-5100A DSTAR Mobile, courtesy of Icom. And we also have a Kenwood THD74A DSTAR handheld. So you must be present to win, and we hope you'll hang around today and be one of the get one of your chances to win that as well. So with that, let's move into our first topic of DSTAR 101, and we'll dive right in. Do you have any other questions right now while we're bringing that up?
So I got to give a few comments here. W5CTQ says there's a group of 15 or so DSTAR users in Tyler, I believe that's probably Tyler, Texas, that plan to watch the stream together. So we have an audience out there in Texas.
Hello, Tyler.
N8PZL, again, what is the agenda? We already got that one in place. And WA9LKZ, does each presenter take about an hour?
That will vary, I guess, depending on the number of questions. And so it won't be about an hour at a time, I don't think, but they'll vary in time, but probably 30, 45 minutes for each one of the topics that we'll cover today within our 4-hour period. Any other questions for right now?
I believe that's it.
Okay. Let's get started. For those of you new to digital amateur radio, there's a little bit of difference. As we all have become very familiar with FM, as your signal level decreases, you start getting some noise, some crackles and pops and white noise coming in, hissy. So looking at the chart, as your signal decreases on the green line, you start hearing more and more noise. What digital voice brings to you is that it does not gradually degrade in quality as the signal level decreases. So you're either in or you're out, and the point where it starts falling off and you get what we call in the DSTAR world is R2D2, or you're losing some bits and it can't recover that, some of the R2D2-like sound, you're already down pretty low if you were on FM, standard transmissions there. So as the red line depicts, your signal goes way out to almost near what would have been the noise level for an FM signal, and then you hit that a little bit of no man's land, and then you lose it all together. It mutes. But you don't have the static and some of the noise that you get when you are in digital. Another factor in digital basics is the bandwidth. In digital, we're converting voice to data, to ones and zeros. You may add additional data, like from a computer or some application program, added to the voice, and we'll explain a little bit of how that works in the DSTAR technology, to produce a single data stream containing both voice and data. And then you modulate your radio as a data carrier. What does it sound like over the air? It sounds like either kind of a buzz or a hiss if you're listening to it on an FM radio. So if you hear that sound, that's what a digital voice signal is going to sound like. Now, here's one of the important things that's a characteristic of most of the digital voice modes. How much space it takes up in the spectrum, or the occupied bandwidth, is usually determined by the bit rate or the type of modulation. And each one some of the digital modes are different, but in general, they have been configured where that they take up and occupy less spectrum than an analog FM. And that's what's shown on the diagram below on the slide. that a standard FM signal, you know, we say it's 5 kilohertz, 5 kilohertz wide. Well, in reality, it's taking up about 16 kilohertz across the band for your typical FM 5 kilohertz signal, because that's a factor of the deviation, and that's plus or minus 5, and then also the audio content, the frequencies that are contained in that. Now, in general, and a lot of this was mandated by the FCC for commercial radio to go to more spectrally efficient technologies such as DSTAR, and so it occupies a whole lot less. It's a narrower signal. The different modes, DSTAR being one of several, DMR, Fusion, and others, all occupy less than a standard FM signal. And what you'll see with DSTAR, it is 6.25, which is about 1/4 of what you see with the 25 kilohertz channel spacing. DSTAR is an open standard, and that's one of the myths that has been out there for years, that DSTAR is a proprietary mode. It is not. It was developed by the Japan Amateur Radio League back in the early 2000 range. DSTAR was one that was developed specifically for amateur radio, not one of them that has been a commercial technology that's been brought down into amateur radio. It's demonstrated that it is an open protocol and an open standard, that you see radios being commercially produced by both Icom and now Kenwood. Just about all of the digital modes, and DSTAR is no exception, it uses the AMBE vocoder chip. That's one of a family of vocoders or voice coders from a company called DVSI, and that converts your analog speech to data and then back on the receive end as well. One of the questions that always comes up is, why didn't we use an open source, or why didn't the manufacturers or the DSTAR standard use some type of an open source voice coder or vocoder for that? And part of that is, yes, there are others that are out there now, but a lot of it depends on the processing power that you're building into a radio. Some of these require a whole lot more processing power. And here is a company, DVSI, that produces these ready-made. They can be in silicon, in a chip, or licensed and embedded in the radio. And then some people will come along and say, well, see, there's some proprietary software in the radio. This is a very small addition to the radio, and just about all of the commercial standards, DSTAR, DMR Moto Turbo, Fusion, and even commercial standards like P25 use the AMBE family of chips from DVSI. Now, what this has allowed also is that DSTAR has really led the way in encouraging a lot of experimentation and open development with a variety of third-party products, and we'll be talking about quite a few of those today.
So John, 84UBM's got a question. I think you just asked it. Why does DSTAR use the AMBE codec? Why not use an open source codec? Well,
we just talked about that. I don't know, either of you want to comment on that as well? But that's, this way there's, it's embedded in the radio. It's a small price addition to the radio. I think I've heard in quantity it's probably $20, $25 to the cost of the radio. And you have a very standardized voice coder protocol that's used. Either of you want to add to that?
The DVSI is the leader in the industry for vocoders. As you mentioned, they are in almost all of the digital protocols that are out there. Even systems like Inmarsat use DVSI for voice. When DSTAR was developed, they were really the only name in town for vocoders.
Well, I'll jump in there real quick. On the very first ID-1s that we had, we actually used an open source codec. And it was later decided by the JARL to go with the DVSI chip because the audio quality at that time, this was like early 2001, 2002, the JARL decided to go with the DVSI chip just because of the MOS factor behind the DVSI chip. So there might be one or two of those that we did not get back in exchange with the later version, but some of the
which one that was? Which codec?
Oh, not off the top of my head. I could do some research, but it was in some of the earliest presentations. And if you look at QEX from maybe 2002, there was a there was a series of articles, 3 articles by John Gibbs on the development of it, and it touches base on the open source codec that was originally used. So that was one of the things that happened on that.
Well, and once the technology was selected, it's very difficult to change that, because now if you went to an open source codec, that would be incompatible with every radio that's out there. So you'd have a new series of radios that couldn't talk to the thousands, tens of thousands of radios that are out there and all of the repeaters that are out there. So
And we could sell more radios than reselling it to everybody, because it wouldn't be a simple blow-in firmware or anything like that.
yeah, and that wouldn't impact DSTAR's reputation at all.
All right, let's change gears a little bit. Let's talk a little bit about the kind of the inner workings of DSTAR. As I mentioned earlier, you're converting voice to digital and transmitting that over the air. It's a 4,800 bits per second data stream, and DSTAR uses the GMSK modulation. That's different from some of the others, but it's just one of the digital modulation formats. Now, if you look at what's in that 4,800 bits, you've got the first 2,400 bits are allocated to voice. Now, another 1,200 after that are what's called forward error correction. Forward error correction allows you, if you start dropping some of the bits, it's built into it where it can restore up to a certain loss of bits back to the original data stream. So that helps at the lower signal levels, or when you're fading, get some picket fencing, or some of those other conditions where you're losing some of the bits. Forward error correction helps you to restore that and maintains that good voice quality. Now finally, that leaves another 1,200 bits for data. What you'll see that used for is a couple of different things. One of those is for sending position information. Many of the radios, in fact most of the newer generation of radios, have a built-in GPS receiver, and so you can send your position along with your voice. Another application is for just sending data applications such as DRATs or keyboard to keyboard, different things like that uses that 1,200 BPS data stream. Now there is a mode in the newer generation of Icom, and I think it's also included in the new Kenwood D74 radio, called a fast data mode. And if you're sending just data, it takes away from some of the voice stream or voice bits, and you can send at actually 3,600 BPS on the data. Now I'll talk about another mode that is gives you a faster data rate as we go along in here as well. But those are the main, that's the makeup of that 4,800 BPS signal that's transmitted over the air. Now remember, the data rate also affects the occupied bandwidth. So a combination of the encoding scheme and the data rate over the air allows that to fit into a 6.25 kilohertz bandwidth signal. Now, if we did some spectrum refarming, we could put more repeaters in the band together. But that will take some time, obviously, over the air, but it does allow you to send more in a narrower amount of spectrum, about half or a little less, maybe around a third of the bandwidth of an FM signal. Now, one of the things that gets confused here, people talk about 25 kilohertz, 12.5 kilohertz, 10 kilohertz. These are the spacing of the channels in the regular 146 to 148 band, or let me go to 440. Let me use that band. They're 25 kilohertz apart, each channel. So you might be at 444.0, you're going to move up 25 kilohertz for the next one. Now, what we've done in that is, and a standard FM signal will fit in that. Remember, it's 16 kilohertz wide, so it's going to be plus or minus 8 on each side. We've started having more 12.5 kilohertz channels in between. We've divided them in half. And then in the 145 to, or 144 and 145 band, we have them spaced 20 kilohertz apart normally. So you're starting to see some of the coordinating bodies interspersing those in the 2 meter band, the 144, 145 band at around in 10 kilohertz increments in between the 20 kilohertz ones. So 6.25 means that it's plus or minus 3.125 on each side of that center carrier. So as you can see, in certain places that the channel spacing has been changed to accommodate DSTAR, we've been able to add some. I know in the former position I had as a frequency coordinator, there were provisions made to add some additional 2 meter frequencies down in the 145, high 144, low 145 band that allowed for some 2 meter repeaters, DSTAR type repeaters, to be added where there were no more 2 meter frequency pairs available, especially in some of the large metro areas.
Hey, John, that's kind of interesting that you go down that tangent on not having frequencies. The FCC several years back decided to refarm the land mobile frequencies because of not having available frequencies to put more customers in for land mobile. They started what was called refarming to go to 12.5. And in that mandate to go to 12.5, they said that they also wanted to go 6.25. And it was very interesting when Kenwood and Icom combined forces to develop NXDN for the commercial two-way. The FCC was being told that 6.25 was impossible to do, that 12.5 was the narrowest that you can do and get good quality audio. The interesting thing about it, we were able to go back to the FCC and say, we've been doing this for a number of years in the amateur radio industry. So that put amateur radio in the forefront of doing testing communications that then goes into the commercial world. So that put amateur radio first again. And it's been a while since us hams have been doing that.
That's right. That's right. There's not an effort underway to really refarm the bands in amateur radio like that the commercial bands did. So I know some of the frequency coordinating bodies have made provisions for more narrowband digital repeater pairs to be added. In the Southeast here, under the Southeastern Repeater Association, some special provisions were made in the 2 meter band, and it added 8 additional pairs for DSTAR at 6.25 kilohertz, where there were, and those have been used widely throughout the state of Georgia and throughout the Southeast for the deployment of DSTAR repeaters, where no 2 meter pairs would have been available before.
And when you look at some of the so-called 6.25 equivalent technology, we're seeing in the commercial two-way side of it where those frequencies aren't available. The only thing that is available is 6.25, and that's where our commercial NXDN technology is able to squeeze in there in some of those major cities. So as amateur radio coordinating bodies start looking at this, we could actually see 2 meter repeater pairs become available without anybody having to die over it.
That's right. And that's one of the things I think that sets DSTAR apart from some of the other modes. You'll see Other modes that, let me use DMR as an example, a fine commercial technology that's deployed for public safety and other land mobile applications. They call it 6.25 equivalent because it's a TDMA signal, which means you are actually transmitting two separate conversations on one signal. But it won't fit in a 6.25 kilohertz channel. It's actually a little wider, so they get allocated to the 12.5 kilohertz spacing channels as well for that. So DSTAR, and you mentioned NXDN as another one, as one of the commercial standards, actually really fits in the 6.25 kilohertz bandwidth. Now, there's another point that is always brought up by people unfamiliar with DSTAR, and it says
That's a nice way to put it.
I'm trying to be nice. Is that you have to have the internet for DSTAR to work. Here's what you keep in mind. If I have two radios operating simplex between point A and point B, I'm operating digital, I'm not on a repeater, I don't need the internet, and I can send voice and data back and forth through those on a simplex channel, just like I can with an FM radio, except I have the advantage of improved voice quality. You don't get the variation with noise coming in with different signal levels. And I can do voice and data. So all of that on a simplex channel. Let's take it one step further. Let's add a repeater. A repeater sits on a high point, a tower, mountaintop nearby, and it extends the range. All of those features that I had on simplex also now work through the repeater. So instead of operating 5 miles, 10 miles on simplex, I can now extend that to 40, 50, 60, 70 miles, whatever the repeater range is. Now let's take that one step further. One of the features that is really a nice addition to DSTAR is that a repeater can be linked to other repeaters or to reflectors, which are just conference bridges basically, where multiple repeaters are linked together, and that connection is made via the internet. If the internet goes away, yes, you use that, you lose that link, but you still have your local repeater. And let's say you're an Aries organization or RACES or somehow serving your local agencies, emergency management groups, you still have the features in your local area over that repeater, over that wide area that the repeater covers. So yes, if you want to talk across the country, around the world, and over a larger area, the internet allows you to do that. However, for serving your local area, a repeater, or even simplex. If you take a 50-watt mobile with an external antenna, you can get across your county or 15, 20 miles away from a high location. So you do have those capabilities with DSTAR, even without the internet.
So John, I think we had a question from the audience. If the audience could, when you ask a question, if you could give your name, your call sign, and question, please.
Yes, hello. Mark Koenig, KM4AJE. I was just wondering, you mentioned the 6.25 kilohertz signal on DSTAR. Is there any, other than that fact, I've always been curious, what is the advantage of DSTAR versus, let's say, these other competing digital modes like DMR, Fusion, et cetera? I'm just interested to know.
Good question. Every digital mode has its advantages and disadvantages. And I try to experiment with all of the digital modes, as most of us here at the table do, and many of you also in the audience. And there's not one digital mode that is best for every single situation. One of the things that all of the digital modes bring you is better voice quality, consistent voice quality. What DSTAR brings is voice and data in the same signal, or you can transmit data only. DMR, I'll use as an example, a commercially developed mode from actually it was developed in Europe as a standard, as an alternative to the U.S. P25 standard. Many of the smaller municipalities have deployed DMR. DMR has an advantage of 2 conversations in one signal. It's a little bit wider signal than a DSTAR signal. So do you have the frequency spectrum available to occupy that? Also, DSTAR has the data where that has not been deployed on DMR in the amateur radio deployment of it in the U.S. It's a good standard. It's a very robust digital protocol, and that's why you see smaller police departments, county agencies, municipalities using it. There's several as you get outside the Atlanta area that are using DMR or the proprietary version of that Moto Turbo from Motorola, which they add some proprietary features to that. One of them is their networking of that, even though enterprising hams have found a way to kind of get around that now, and you'll hear the term Brandmeister, and that is a way to network without using the proprietary Motorola networking protocol.
And there is one thing you might want to qualify just a little bit, and that is when you're talking about audio quality. I've heard many comments at different shows, well, DSTAR in a digital mode sound a little robotic, where FM sounds so much better, but qualify a little bit where the signal enhancement is much better with digital.
Well, as you go back to the slide that I had earlier, I think it was the first slide, once you are digital, you're going to have the same voice quality, and we're not talking about CD high definition audio quality with this, because you're still only using the voice frequency range. Some people will comment that one particular mode over another may sound a little better, and some of them use different variations of the AMB family of vocoders.
Which use more bits.
But in doing that, you use more bits, which means more bandwidth occupied. You can kind of say there's a trade-off there, I guess. When let me give an example. Ed and I have talked about this a lot of times. Both of us do serve as a net control for the Southeast DSTAR WeatherNet, which is on Sunday nights, 9 p.m. Eastern Time on Reflector 2 Alpha. We get accustomed to listening to a digital signal, like a DSTAR signal, and it's so clear. How many of you have run FM, have been a net control for an FM net, especially on a linked repeater network? I know we have several linked repeater networks, FM repeaters linked together in the state of Georgia. And you listen to them, and they're linked together, varying audio quality. Some will be muffled, some will be clear. You hear some having the courtesy tones, some hearing beeps and boops. You don't hear that when you're networking digital stations together on DSTAR. On the Southeast DSTAR WeatherNet on Sunday nights, we have how many? 20, 30, 40 repeaters together, linked together, and about 50 to 75 users checking in, all within an hour. And it's just so easy to be net control. Now, there's another feature with DSTAR that you don't have with someone like DMR. Your call sign is transmitted over the air. Because DSTAR was developed specifically for amateur radio, your call sign is what's transmitted over the air. I say this quite often. If you're a repeater kerchunker and want to remain anonymous, DSTAR is not for you, because your call sign is visible on every DSTAR other radio that's listening to that repeater or that frequency.
That's something that new DSTAR users learn quickly.
Yes. DMR, for example, because it's coming out of a commercial world, you have a radio ID. And you have to essentially put a lookup table, your contact list, in the radio to translate that to a call sign. And you're constantly updating that. Let's say you get a new DMR radio tomorrow. If I don't put you in there as a contact, which says 3212001 is W4ABC, then I'm just going to see that radio ID. So that works out very well, especially for emergency communications. You see the call sign. If I didn't quite hear the person, they didn't speak real clearly, I see the call sign. I don't have to worry with that.
And on the newer radios, as you mentioned, you've got the location. So someone out in the field can key up, say help, and you've got their call sign, you've got their location, and you've got what they need.
And then back to the nets a little bit. My YL, for everybody on site you met as you signed in, she calls the weather net on Sunday evenings periodically. She really loves to do that because she can hear everybody. But one of the things that we've got is a couple programs. One of them runs on the repeater. One of them is DV Pro. Basically, you can then use your computer, hook it up to the radio or watch the repeater, and it shows the call signs coming in. So for the weather net, we can call the net, check in 70 people, get every call sign essentially correct. Sometimes we can't read a screen, and call everybody back without ever writing down a single thing. How many FM nets can you do that on? So that's one of the advantages is you get these call signs and some of the capabilities built into this that makes some really nice features. Also, John, how do we check into the net?
We've kind of pioneered through several of the early nets what's called a quick key format. Let's say I've got 8 states checking into my net, and I say, Alabama stations, please quick key now. If they key their radio, I see their call sign. It comes up in the software application that Ed's talking about, and I get a list of them. So 10 stations can key their radio. I see a list of call signs, and then I can go back and call them back one station at a time. I've got the list. So that makes for quick check-ins. Those 75 check-ins, and we've had close to 100, I think, on a real busy night. You can get through that whole net in less than an hour, and you've contacted every single one of those stations. But you don't have to go back and keep asking for information.
And that's mainly because hams like to talk, so you need to go back and talk to them. If it was just a check-in to say you were here, you could do that in literally a few minutes. Everyone would just key up, you'd get their list. You wouldn't say anything to them, they wouldn't say anything to you. The world would be great.
I've actually seen a variation of that where in the text message, they'll put traffic, no traffic, or emergency traffic, and that comes across on your screen as well, all in a quick key.
Yeah, and that's important to note that you do have a short message field that if you transmit it with your radio, you turn on the message, then you can have a short message. It could be John in Lawrenceville, Georgia, or it could be that I'm on an ID-51A, or it could be some other short message, EOC in Atlanta, Georgia. So those are opportunities you can do. We've got a question up here on the front row, Nick. Or over here. Let me take this one first. He's got the mic.
This it's Norris Klessman, N9XGZ. This is going to be a little off. But with the past where the FCC has been trying to take bandwidth away from people, they've talked about taking amateur bandwidth away. And with the changes that are being made in Washington, let me read this. Do you see the FCC taking bandwidth and moving amateur radio strictly to digital?
That's a hard question to answer because I'm not in tune with the FCC. It's a good question. I thought where you were going with that question was if we start going with narrower modulation schemes, are the FCC commissioners going to say, you don't need as much spectrum?
That's what I'm
But really what we're doing, we're opening up the ability. If you want to put a 2-meter repeater in Atlanta, Georgia, Dallas, Texas, Los Angeles right now, there's probably no way there's probably no frequencies available. What this is allowing to do is open up some additional frequencies that people are wanting to use, rather than saying, okay, we can compress the band down and the FCC is going to take it away from us like they took away some frequencies on 220.
Well, one of the other things is going digital and doing different things like that advances the hobby. If we just focused on a push-to-talk solution instead of some of the other things that we can do with that spectrum, why would they allow us to keep it if we're not advancing the hobby?
I mean, that's one of the things you see in Part 97.1,
Right.
one of the opening statement in the FCC rules, that you are advancing the hobby, new technology. And you see a lot of new technology can have its roots in amateur radio.
And also, when you look at Part 97, it talks about us assisting for emergency communications. Another threat to us is having the egos in place that we're communicators without fully understanding what our served agencies want and need. And it doesn't matter how many words per minute you can send in Morse code. They're looking at moving files and moving data at this point. And one of the mantras is, why say it when you can send it? You don't have dialect. Is that Bravo or Victor when you say B, when you can send a spreadsheet of information? So the biggest focus is to get away from the push to talk and look at all the different after action reports that come from a lot of these big disasters. The wildfires in Colorado was a perfect example of where they said they needed more accountability. And if you read that, what it sounded like they wanted for amateur radio operators were to be scribes, to document what was being said. And honestly, I don't want to sit there and take notes. I'd much rather be moving traffic that shows what time we did it, where we were located, who we sent it to, and things like that, over our technology that we can do regardless of whose radios you're using.
So here's another question from KB1WAL. When will the FCC allow faster transfer speeds, not just on the microwave bands, but for example on 2 meters? And my response is, one of the problems, especially on 2 meters, there's not enough room for all the amateur stuff in there now. If we were able to make a lot of the signals much narrower to the degree that DSTAR is, we would have more room, and then we could maybe start fitting higher speed communications in there.
But it also goes to how much bandwidth in the band to move the amount of data that they're doing. If you look at P25, that was a progression to move to 700 and 800 megahertz, and they were talking about data in 700 and 800 megahertz of being 3 continuous 50 kilohertz channels. So you'd have 150 kilohertz of bandwidth. Well, in the DD mode of DSTAR, we're able to do 128K bit per second. With the advent of LTE in the direction of public safety to going towards LTE, you're able to move a lot more bandwidth. So trying to move that down into the lower segments of the amateur radio bands, I don't see, because of that congestion and how much bandwidth that they need.
Let me add one more comment to the previous question, and I know we have another question here in the audience. Most of us are pretty active in emergency communications, ARES here in Georgia. We can, when their communications, when emergency responders' communications goes out, what they're looking for is not so much replacing the voice, they want data. Let me give you an example I use. Some of you here are tired of me saying this example, but it's a real simple one. Can you spell ibuprofen phonetically? I can't spell it for sure just using letters. But if I try to send it India Bravo uniform, okay, I'm lost after that.
Papa.
And so on and so on. So if I can cut and paste and send that as data, we're golden. We've proven our value as amateur radio communicators to them.
And there was a group of hams in Arkansas that did a test, and it was 3 medium-sized sheets in a worksheet in Excel. A group of hams were doing it phonetically. Another group was using DRATs to transport an Excel spreadsheet at the 1200 bit per second that everybody says, well, that's so slow. We can do packet faster than that. Before they got finished with 10 rows of information, I think it was multiple rows and 5 columns of data for hospital supplies, they had already sent the 3-page spreadsheet. So that's what they're looking for is a volume. I have no idea how long it would have taken them on code.
Okay. We had a question here locally.
Yeah, thanks. I'm Mike, KK4ZR, new to DSTAR. When you were talking about your nets, your weather net on Sunday night, how does DSTAR handle potential of 2 stations doubling with one another?
Well, it's the same as in FM in that you have the same spectrum being transmitted. So in DSTAR, you don't get a capture effect like you do in FM. The 2 stations will walk all over each other, and that you'll hear what John referred to earlier as R2D2. And so you can hear the garbling of the information, so you can't capture. And one of the 2 parties will have to back off and key up again, or net control will have to call. Often it's not an exact key up, so you get the header of the packet of one of the 2 people, so you can see who keyed up, and you can go back to them and say, okay, you keyed up first. I see your call sign, but your audio was garbled with another transmission. Go ahead and make that, and then go back and call the second person that keyed up.
Okay, very good. Let me go back to some of the information
think we
here.
got another
You got
question.
another question? Okay, go ahead.
I'm Dave W4DTR. With the data, if you needed to send more data in a shorter amount of time, can we do any sort of channel bonding?
Not at this time.
But that is the difference between low speed and high speed data. The low speed uses half the channel, whereas the high speed uses, or low speed uses a quarter of the channel, where the high speed uses about 2/3, 3/4 of the channel.
And as John mentioned, the newer radios have a higher speed mode where they take the bandwidth that's normally used for voice and error correcting, and they add that, so you have higher bandwidth, even though it's still 3,600 bits per second, which is relatively low these days. So it's 3 times the speed of a standard DSTAR data stream.
Right. But the newest generation of radios, the newest Icom, the new Kenwood radio, all have that fast data mode. So you can do that at 3,600 BPS, 3 times what you could over the 1,200. Okay. That kind of gets us into a couple of areas. I think Ray mentioned a minute ago. On 1.2 gigahertz band, there are radios that will actually, they can strictly function in a data mode, even though they can also do voice. But you can increase your speed to about 128 kilobits, a little less than that usable. But that's in the 1.2 band. That can be useful for kind of an Ethernet bridge. It actually has an Ethernet jack or a plug on it to be able to connect in, so you can do kind of a last mile on 1.2. We were talking last night, I believe it was, about that we did some experiments of actually flying an ID-1 radio back with our local Aries group, and we were able to send back pictures. They were a little lower resolution, but they were still sufficient to be able to serve the purpose that would be needed. It was interesting that we were sending them back on 1.2 gigahertz from the airplane, take a picture, send it back, and we were uploading them to the Google Picasa site. What we didn't realize is that we had some folks down at the Georgia Emergency Management Agency State Operations Center who was also, we had made the link available to them, and they were coming back, we like your pictures. So we had seen those. We flew over a water treatment plant about 25 miles from here. They flew on down the road up to Athens, Georgia, flew over the University of Georgia Stadium, and we could actually use the Picasa feature to do a before and after. So let's say there had been some kind of event there that had either caused property damage, whatever. You could use the Google Photos before and after to compare that. And we were able to send those near real time with the 128 kilobit mode.
And so talking about brownie points, having the Georgia Stadium on the big screen in the Georgia State Operations Center was just really nice brownie points.
Maybe for Georgia graduates, but
Next one, we'll fly downtown and do Georgia Tech. All right, we talked about automatic position reporting. DPRS is kind of we call it the DSTAR equivalent to APRS. And so you can send on that 1200 BPS data channel, that's a part, or the bits associated with that, you can send position information. So every time you key up, you can have your information reported. This can also be routed to the APRS.FI or the APRS-IS network so that you can also see, along with APRS stations, you can see the position information that's being sent as well. So it's nice in that it's self-contained, while the Kenwood D74 has great APRS capabilities in it to be able to send your data along with just a single DSTAR radio and a DSTAR signal without having to have an external TNC or a tiny track or whatever your device is, can be a real advantage.
John, I got a question back at 1.2 gig again. From KC0ITF, what is the future of 1.2 gigahertz DSTAR?
We're going to let someone answer that.
Well, right now, the only radio that we have in our product line on 1.2 is the 9100 in DV mode. There has been a call for a new ID1. I'm not sure what type of development looks like for a replacement for that, but I know there's still a lot of them floating around out there that if people aren't using, that they can sell to the cause.
how does the 9100 in DV mode differ from the mobiles or handhelds in DV mode for data?
It's the same way, but it does not have the fast DV capability in a 9100.
All right, we talked a little bit about repeater linking. There are, I'm going to say, hundreds of reflectors. Now, I mentioned earlier, reflector is like a conference bridge that multiple repeaters can connect to. Also, you can connect some of these devices that we'll talk about a little later on directly to these reflectors. There's different, what I'll call flavors of reflectors out there. The original ones were developed by this guy over here through some add-on software that resides on a lot of repeaters called D+. And then there's a network of, is it over 80 now, I think, D+ reflectors. They're indicated by REF and then 3 digits. And within each one of those reflectors, they have up to 5 different modules within it. One of those is used for an echo test, or you can say something tuned to that reflector module, usually E, say reflector 30 E or echo, and then it will play your audio back to you, so you can use that as an echo test.
And that's a good way to test your connectivity. Normally with your device, you can do an echo test locally, you can do it to the repeater, then you can do it to the reflector, and you can see where in that chain your network connectivity may be breaking down.
So with these reflectors, a lot of them are linking together for state networks here in Georgia. We have reflector 30 and reflector 30 Bravo, the B module. Usually is every repeater, every DSTAR repeater in the state has at least one of its modules, either UHF or VHF, connected to that for kind of a statewide network. We also use reflector 30 Charlie, has become kind of a national, international gathering place. It's one of the 2 busiest reflectors in the world, 30 Charlie. So many of you, I'm sure if you've been on DSTAR very long, you've landed on 30 Charlie and talked to Australia or Europe or California, as it may be.
And that server is located in a data center here in the Atlanta area.
And generally, the reflectors need a higher bandwidth connection and a reliable one. You do see some of the other flavors of reflectors, like the DCS and XRF reflectors, that they may be operating from someone's home on a DSL or cable connection and may not be as reliable. But Robin has been the innovator of the D+ reflectors, and I think has certain standards that they must meet for bandwidth and reliability to provide a very reliable and stable resource.
John, is there a list of reflectors somewhere?
I think I'll let you go ahead and answer that question.
So indeed, at dstarinfo.com, we do have a list of the reflectors around the world. We've got the reflectors and then the owner's desires for the communications that's on each reflector. So there are some reflectors that are Italian language only. There's all sorts of different reflectors for different conversations around. The busiest reflectors are probably Reflector 1 Charlie and 30 Charlie. Those pretty much day or night, you can find somebody listening to those things and talking.
So you're either linking a repeater to a reflector, or if you have one of these other devices that I mentioned, a DV dongle, DV access point, hotspot, one of those devices that we'll spend a little bit more time later, you can link those directly to a reflector, but other than that, you're going to be linking a repeater to a reflector. We've got DSTAR radios in a variety of configurations, mobiles, handhelds, and even repeaters. They're commercially produced by two of the, I'll call three major amateur radio vendors, Icom and Kenwood. The DV dongle was kind of the first non-radio device, and Robin will talk about that more since he is the innovator and designer of the DV dongle.
Along with Mo Wheatley, AE4JY.
And this allows you, without a DSTAR radio, to get on the DSTAR network and talk. It's similar to Echolink, but I call it Echolink on steroids because you have more capabilities. The DV access point creates a low-power hotspot. There's a variety of those that are now entering the market. People are connecting hotspots to mobile radios to create one with a larger area than just the 100 milliwatt versions of those. And then you'll see node adapters, which is actually like a GMSK modem. So you can take a standard radio that usually has either a data input or you're getting to the modulator and discriminator of that radio and convert it into a DSTAR hotspot or a repeater itself. So both of those are options, and we'll talk more about DSTAR devices. Here's a typical configuration of a fully configured DSTAR repeater. I'm showing the Icom repeater modules. Starting at the bottom, the RP4000 is the UHF version, 2000 2-meter. RP2V is 1.2 23 centimeter voice. The RP2D, that's doing your 128 kilobit data, and all served by a common controller, the RP2C. Now then you have this external Linux PC running gateway software, and that allows not only internet connectivity, but it's also the host of a lot of third-party applications. That's where D+ for repeater linking resides. That's where support of the DV dongles and access points. That's where some of this other software used for net control, or Monlink is one developed by Ken Atkinson and WB4FAY over in Birmingham, that you can have announcements on your repeater or automatically link to a certain reflector at a certain time and have certain functionality. All of those can reside on that Linux PC and then connected to the internet.
So John, we got a question from AA9DU. Are there still opportunities for a radio club to acquire a DSTAR repeater at special pricing? And can you discuss stop there first.
Actually, yes, there is. Announced just at the beginning of this show is our new Buy Direct DSTAR program. You can by the controller and gateway software, the RF modules for digital voice, as well as the DD mode module. It is on our website. When you log in to our website, you go to the amateur radio, and towards the middle of the bottom row, there will say current specials. And you click on that, and it will give you the information for it. And one bonus that has been added to it, if you buy a complete DV stack, meaning the 1.2 gig, the 70 centimeter, and the 2 meter, we will give you the DD module for free.
So here's a question from AD5RB. Any plans for updating the repeater modules and controller?
There's been no plans to do anything other than to extend the life of the product. We are in a version 26, which a lot of the DSTAR sysops that have put them in place have realized you don't have to go with the preamps anymore. So the RF modules are a lot more sensitive, and that occurred about 6 years ago.
All right, I want to take just a few minutes. I don't want to dwell on this, but talk about registration. This is an often confusing issue, but the question is, why do I need to register? Well, the short answer is you don't. But if you want access to some other features, it's a good idea to do it. It's not required to get on one of the other types of gateway repeaters, IRC DDB as one example. But if you do register your call sign, it allows access to certain functions on D+ repeaters and reflectors, and it will allow you to actually issue linking and unlinking commands.
There is one other thing to add on this. The requirement for registration, if it's going through the Icom G2 or G3 software, one of the reasons why we did the registration is there are some countries that do not allow third-party communications. So they want a level of validation that who's coming through the system to their country is a registered ham. And instead of us trying to be the policing agency or different country representatives to do that, we decided to allow the repeater or the sysops or the repeaters validate that who just registered was a legitimate ham radio operator. So while there are some countries that do not allow third-party traffic that are running some of the other gateway softwares, the ones that have been Icom sponsored and Icom supported, we won't support gateway softwares that do not require registration.
And to repeat what John said, as a new user, you do not have to be registered to talk. A new user can get on the radio today. It's a very common misconception that you have to be registered to talk. You do not have to be registered to talk.
Again, that just gives you access to additional features if you want to link and unlink. Now let's go through very quickly how you do that. Let me mention this as a key thing. If you are going to register, you want to register on one and only one gateway system. Typically, that'll be your local repeater. Unfortunately, there are some system administrators who don't check that very often, and sometimes that can be delayed in getting approved. The process is a 3-step process, and we'll go through those steps. Step 1, you're going to log in to your local repeater gateway, and typically, if it's one of them that is a registered with the DSTARgateway.org domain, you'll get to it by going to the call sign of that repeater, .dstargateway.org/D of dstar.do. That'll get you to a page that looks like this. This is for a G2 system, which is only about 3 dozen G3 systems, and we'll talk about and tell you the differences there. But this is the screen you can expect. So looking at the bottom of the page, new user, and click register. You're going to fill out your call sign, your name, email address, and you're going to select a password. Certain repeaters may have some verbiage at the top that says, I agree to behave myself, I will follow the rules, and I'll be subject to deletion if I can't follow the rules. And so they're going to want you to say, do you agree? So yes. So once you filled out this information, remember your password, click OK. The system administrator will then go in and do a validation. Here's what Ray was talking about.
Hopefully in a timely fashion.
Absolutely. They will do some checking to try to validate that you are truly the right person assigned to a call sign, some validation, and hopefully that you have not tried to register or already registered on another system. And then the step 3, you're going to have to come back and do one thing. Now this screen will look a little bit different on one of the new G3 systems, but like I said, there's only about 3 dozen of those right now around the country. You're going to go back in and add what we call a terminal. And so you're going to check that number 1 box, and then you're going to go to that initial box and just hit the space bar. Put a single space in there. Go out to the right, and then you're just going to add, it's kind of like an alias for you. Once you do that, then you click update, and you are good to go. You really only need to fill out one of those. There's a common misconception that I need to have a different terminal for every radio that I have, handheld, portable. No, you do not. Use the same for each one. Now, there was a practice back early on that someone said, why don't you add an A, B, or C or something like that if you're operating on a dongle or a DVEP? Unfortunately, that added a lot of confusion.
And now we've added that back.
And when you enter the call sign in your radio, people were not putting that suffix in or not registering a terminal with no suffix on it. So that
there are
caused
2
some problems.
places now that you do need. You're going to cover that?
I'll cover
Go
that.
ahead. Yeah.
I'll cover that later.
Okay. There are very few places that you need to do that, but for most users, especially a new user getting on, just put your call sign in there. Don't put anything in the suffix column.
But this is kind of confusing. Are there instructions anywhere?
There is a good document that someone produced.
Let me guess, dstarinfo.com.
No. Actually, if you go to www.dstargateway.org, someone named AA4RC produced a very nice document that has step-by-step with screenshots on how to do that. So if you follow that document, when someone registers with our local repeater here and I approve them, then I say, go back and add the terminal according to the instructions on the document at www.dstargateway.org.
And so those instructions show me how to do it at W4DOC. Should I do it there?
No, do it on the repeater that you registered on. Even though the screenshots say W4DOC, do it on the repeater where you registered.
I thought I'd changed that so that it didn't say DOC anymore. We
Maybe
get
have.
20 or 30 registration requests on W4DOC every week.
The final thing that you want to do, and if you go buy a radio, if you leave here today or and go by your local HRO, Gigaparts, R&L, whoever dealer, and decide that you want a DSTAR radio, you can get on immediately, because one of the things is, and Ed will cover this in more detail, you have a database already in the radio. So all you need to do is to add your call sign in what's called the My Call field, the My field, or in the menu, I think it says Your Station, or My Station is what it says. And you add your call sign, type it in there on the keypad, and you're ready to go. You can get on the air immediately, even without a registration. What the registration will give you is not only that validation, but to be able to link and unlink, which we'll talk about a little bit later on.